Good morning, students. In today's class, we are going to discuss about the implementation of support vector machine. So, as we discussed earlier, that SVM is a supervised machine learning algorithm, and it will look at the data and sort it into two different categories. So, you can see in this example, like I have a banana, apple image and a strawberry image, and I'm giving the model to learn about the features of apple and the strawberry, and I'm giving a new data after the learning of the model. I'm giving a new data which is having color, which is having no color in the image. You can see here the image is having no color, so there are some features which are missing, and I'm giving to the model. I'm expecting the model to give me the result, and you can see here model is saying that it is a strawberry. So we discussed this thing in the theoretical part of SVM, and we discussed that whenever we are talking about SVM, SVM can work better if there are some of the features are missing also. In that case also SVM is performing well. So we discussed all these things in the previous class. Now in today's class we are going to discuss about the implementation of SVM. So we'll start with the implementation part of SVM. So, first of all, as we have discussed in the earlier lab sessions also, first of all, I have to import the data, with me. So, here I'm using the Google Colab. So, from in Google Colab, I'm importing the data file. So, I'm using here social network advertisement data, and I'm importing that particular data into Google Colab. So, this is the code for importing the files. Okay, so we have imported the file here, and then just I want to, whenever I'm working with the CSV file, I have to import definitely NumPy and pandas library, as well as we want to draw some graphs, so we are using here matplot. So all the libraries we have imported here. Now, before discussing further about the implementation, first of all, I would like to tell you how my data set looks and what exactly the data set is. So, this particular social network advertisement data set is commonly used data set for classification problems. So, many of the people are using this data set for classification purpose. And if I want to analyze the social network or the people behavior on the social websites, if I want to predict the behavior, then this data is can be a good choice. So this data set includes information about the user, their interaction with the advertisements on social networking platform, and basically our goal here is to predict whether a user is going to purchase the product on their age, gender, and estimated salary. So I have in this particular data set, I have the age, gender, and the salary of a particular person, and I want to know that of certain age person or certain gender and having so and so salary is going to purchase something or not. So that could be my prediction here. So first of all, what we are doing, we are reading a CSV file. So to read the CSV file, we are always using Panda. So I'm using LISO Panda, which is PD, and I'm reading the CSV file. And now I want to just display the first 5 line of my data set. So you can see here my data set is consisting of user ID, gender, age, estimated salary, and the purchase detail. So these are the features which are available: age, gender, and estimated salary. And purchase is the outcome of my what we can say data set, like person is going to purchase or he is not going to purchase. So now we know about the data set now. So now what I have to do, I have to split the data into training and testing. Okay, so before splitting the data into training and testing, what I have to do, I have to split the input feature and the target feature first. So I have to use this splitting of input feature as well as the target feature. So what I'm using here, I'm using two variables, X for input features and Y for target variables. Target feature we can say. And I'm using I location here. So what I want all the rows which are available in my data set. So every person information I need. And I'm concentrating on second and third value. Okay, so I'm this is 0, this is 1, this is 2, and this is 3. Fine. So I'm considering age and the salary for prediction purpose. Fine. So I have taken this, and then I'm using I want to keep my target variable into the y variable. So I'm taking all the values, and I just want the target variable which is represented by 4. This is 0, 1, 2, 3, and 4. So purchase is 4 for me. Fine. Now I have splitted my data, training data, I splitted my data input features as well as the target feature. Now I have to split the data into training as well as in the testing. So you know already we have done many times this. I'm splitting the data into training and testing. So I have used xtrain, xtest, ytrain and ytest. And I'm splitting the data. I'm using here 75-25 ratio. 25% data I'm using for testing purpose and 75% data I'm using for training purpose, and we know we have to use random state, so we use here random state equal to 0. Now the next is I have to scale down my data. I have to normalize my data, so I am doing here feature scaling. So feature scaling is helpful for normalizing data into a particular range. As we discussed in earlier classes also, that if I have my data into a scale of 0 to 1000 and I want to make it as from 0 to in the scale of 10, then I'm generally using standard scalar. So same standard scalar function we used in the KNN algorithm also. So same we are using here. We are using standard scalar function and applying on the training as well as on the test data. Now, after this, we are trying to fit the SVM to the training data. Now I'm trying to fit my model. Okay, SVM model I'm trying to fit. So what I'm using, I'm using support vector machine classifier from the sklearn. We are importing from the sklearn library with we are using sklearn library for importing purpose, and I'm using here radial basis function kernel to fit the model to our training data. Okay, so this is for fitting of the data. So we are using a classifier and I am fitting my data between X train and Y train. Okay, so I'm fitting my input features as well as target values also, and I'm using here RBF. Clear? Now I have to predict the test results. So now what I have to do? I have to predict my test result. So for predicting the test result, we are using y predict equal to classifier dot predict of x of test. So this is used to predict for making the prediction of new data, because we have done the training of train data x train, and I want to test my model on the test data. So I'm using here x test. Fine. So we are evaluating the performance of the model on the test data. Clear? Now, so this is we are fitting the model. We are fitting is nothing but we are training the model, and then I'm trying to predict the result on the test data also. Fine. So we have done this. Now at the same time, I want to make a confusion matrix. I want to evaluate the performance of the model using confusion matrix. My confusion matrix, as you know, that it will give me the result of true positive, true negative, false positive, and false negative. And if I have all these values, I can work with accuracy, precision, recall as well as on F1 score. Okay, so here we are using confusion matrix. Clear? Now, what we are doing here, we are using the confusion matrix. I'm importing the confusion matrix from sklearn, and I'm drawing the confusion matrix between the predicted value and the actual value. So y test is representing the actual value and y predict is representing the predicted value, and I'm displaying the accuracy score also on actual value as well as in the predicted value. So you can see this is your confusion matrix and this is representing the accuracy. So our model is giving the accuracy of 93% in this case. So I hope it is clear to you that how it works. Clear? Now I want to plot the same graph here. So whatever is there, whatever we have done, I want to plot a graph in this way. So I want to plot a graph between the age and the estimation salary. I have taken two features as we discussed earlier. We have taken age and estimation salary. We took two features and we want to plot a graph using matplotlib. So we are importing the matplotlib and we are trying to plot the graph here. So when we are plotting the graph, you can see here my graph will look like this. So you can see here we have five values which are sorry, we have six values, not six actually, we have seven values which are predicted wrong. So you see here, there are some data points which are predicted as red. Red is representing that they belong to zero class and green is representing that they belong to class one. So if it is red, it means they belongs to, it should belongs to class zero. and if it is a green, they belongs to class 1. So you can see here these data points were green, but they predicted wrongly these 4 data points. In the same way, these 3 green data points also predicted wrong. So that's why our accuracy is not 100% because of some wrong prediction. We are getting the accuracy of around 93%. So this is our wrong prediction. So understood? I hope it is clear to you that how SVM works. Thank you.